looking at the gradient of a line when we're looking at a graph. So let's have a look. What is a gradient? A gradient is the slope of the line. We've already learned how to say whether it's positive or negative or zero, undefined. And the gradient is the y change over the x change, which is basically your rise over your run. So get that into your heads, make that a rhyme that you remember: rise over run, rise over run, rise over run. Let's have a look at it. So first of all, this says find the gradient for each of the lines. Now, when you've got a line like this, there's a couple of things you can do. You can choose 2 points. Now, your points have to be convenient points, they call them. Ones that cross, can you see there that crosses directly through the corner? This one crosses directly through the corner. This one doesn't. This one does. That one doesn't. This one does. So we've got to choose 2 points. In this one, we're going to choose this point, and we're going to choose the top one here. And we're going to draw a line, and you can do this in your head or on the piece of paper, where they meet. So there we've gone one to the right, which is now called your run. Okay, your run always goes from left to right. Always. Okay. Your rise can go up, which means it's positive, or it can go down, which is negative. Okay. But the run always goes from there, from the beginning, to the right. Okay, there's only one direction. So if you ever find yourself drawing it on this side, you realize that you're doing the wrong thing. You hear pouring rain outside, so just excuse that. Okay, so we've done our run, and then we do our rise. Then we count them. So we say, okay, well, our rise went up 1, 2, 3, 4, 5, 6, and our run was 3. And you put your rise over your run. So 6 over 3. So your gradient is your y change over your x change. Your gradient was 6 over 3. And you know that you bring that down to as low as you can. 3 goes into 6 twice. So therefore, your gradient is 2. Beautiful. So let's do this one. So we start off by saying, let's find 2 convenient spots. So we'll say that one, and we'll say that one. Any 2 spots will give you the same answer. So we start off with our run, which goes from left to right, our rise. Right, now we put the rise first, and our rise is 3, our run is 5. Our formula is a y change over the x change. The gradient is equal to 3 over 5. We can't bring that down any further, therefore that's where it stays. Okay. This one, let's just move this little goody thing over here. On this one, we've got our run. Remember, it has to go from left to right. And then our rise, which goes up. And there we've got 6 over 3. So the line slopes from the left to the right. So it's a negative gradient. So you can see, so you know that it's a negative gradient, therefore, and the negative always goes with the numerator. So therefore, you would go negative 6 over 3, and you know that 3 goes into negative 6, negative 2 times. So therefore, your gradient is negative 2. Right, so let's start with this one. Now we have to choose 2 convenient spots. So we're going to choose that one there, and we're going to choose the one above it. So that would be your run, that would be your rise. Your rise is 2, and your run is 3. So therefore, the line slopes from left to right. It is negative as well. So therefore, we say negative. We always put it on our numerator, negative 2 over 3. We can't bring that down, so that is our answer. Another lot. Our run is our rise. So our run was 2, 1. Our rise was 1 over 2. Can't bring that down anymore, so it stays like that one. This one, our run was 2, our rise was 6. Rise over run, it says this slopes from left to right, so it's negative. So that would give us negative 6 over 2, which gives us negative 3 as our gradient. Let's go straight up and down. Now you've done one of these. What does that mean? You know we've got a rise of 6. There's no x change, so the value of that is 0. So therefore, the gradient is 6 over 0, which gives us a gradient of 0, which is undefined. We can't get one. Going all the way across the x-axis. So there's no y change, so the value of this is 0. So there we go. The gradient is 0. Going all the way along.